Prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 times that of the volume of the sphere. Now, what does it mean? What does the word inscribe mean? So to understand that, we have to go to this. So what is that we're looking at? We have a sphere and inside that a cone. The cone is in such a way that it's touching the edges. With these edges, it's touching the sphere. It's not coming out of the sphere and it's not too small, right? So it is in a manner wherein it's touching the sphere always. Even if I vary the size, for example, other possibility is this. Even though I'm varying the size, it's always touching the sphere. So like this, there are infinite number of possibilities. So the best possibility with the largest size is this particular expression is what we have to prove. Right? Again, inscribe means it's the cone is touching the sphere in with its edges so that it's the best possible fit for that particular scenario. Okay, so we have to consider and we need to draw as well a sphere and a cone similar to this, whatever I have drawn or copied to be more precise. So this would be your radius, this would be should be doing that actually. Yeah, that is not required. Okay, so this is the center of the sphere and okay, this is your radius, that's your radius of the cone, and this is the extra length from say O to A, B and C. Okay, OA is X, AB is R, OB is capital R and OC is capital R, indicating the radius of the sphere. So we'll start off with let R comma X represent AB comma OA. Then what do we have to prove? To prove volume of the cone is 8 by 27 times the volume of the sphere. Now the proof. So I would like to start off with writing the volume of the sphere with radius r. So that is 4 by 3 pi r cube. Next, volume of the cone is 1/3 of pi r square h. So we have h as, we need to substitute h as r plus x. So x value can be positive or negative depending on the scenarios. And r will be equal to, r square in specific will be equal to, this being right angle triangle, r square minus x square. Pythagorean theorem. Okay, yeah, that's correct. So therefore, volume of the cone is equal to 1/3 of pi. So we have this to be r square minus x square times of r plus x. Okay. Now, so to move forward, what should we do? Yes, we need to differentiate because we need to find the critical points. So differentiating volume of the cone, so v of x, because r is constant, remember. So here r is fixed. Okay, that's why I'm not taking it as a variable over here. It does not vary. That's the whole point, right? Variable is something that it varies, but here r is constant. So we are not considering So we are not considering it over here with respect to x. So v prime of x is equal to 1/3 of, we have to use product rule over here, opening a big brackets, differentiating this, so this will be minus 2x into r plus x plus differentiation of this particular expression is 1, okay, because r is constant, remember, so 0 plus 1 basically, right? So differentiation of, while this would be, let me make it a bit clear. I think, I mean, you guys should not be confused, but still. Okay, differentiation of the first term is what? Differentiation of r square is 0 minus 2x. Actually, this is not required, but I'm just doing it for your understanding. Plus the second term, right? Plus first term into differentiation of the second term. Closing the brackets. Now, continuation to find the zeros of b prime of x. Basically, that is your critical point. So we have 0 is equal to 1/3 pi, and further expansion minus 2rx minus 2x square plus r square minus x square. So this clearly gets cancelled, ones are and zeros are. A bit of simplification. So what do we get? We have to get expression for x in terms of r. Basically, it's very clear, it's going to come. So we have this to be 0 is equal to, so minus 3x square, okay, minus 2rx plus r square. So if I multiply throughout with minus 1, or if I transpose also, then that is okay. If I transpose all of this onto the left hand side, we have 3x square plus 2rx minus r square is equal to 0. Does it make sense? Now, we need to simplify this. So let's make use of discriminant, which is b square, right? So this is solution for above equation, quadratic equation. So we're going to find discriminant, which is b square minus 4ac. So here b is 2r the whole square. We are considering x as the variable, and those are the constants, coefficients and the constants. A is 3 and c is r square. C is minus r square. So this would be 4r square, this would be plus 12r square. So all in all, this is 16r square. That's a good number. Actually, I could have split the term itself. That's simpler, right? 3 ones are minus 3. Okay, I could have done that directly. So this would be 3x square plus 3rx minus 1rx minus r square is equal to 0. That is, when I multiply, I should get 3 into minus r square, that is minus 3r square. So plus 3r minus 1r, so minus 3r square. When I add, I should get this, which I am. And so we have this as common, 3x as common. So we have this to be x plus r minus 1 as common. So we have x minus r as common, my bad, is equal to 0. So we have x plus r times of 3x minus r is equal to 0, right? So we have, therefore, x is equal to r minus r, comma, r by 3. So these are your two critical points. Now we need to find the maximum value. So for that I need to differentiate with respect to x. So the expression is over here. This is a simplified version, right? So double prime of x would be 1 by 3 pi minus 2r minus 4x minus 2x. Remember, r is constant, capital R, right? So let's further, can I simplify this further? Yes. Actually, I could have simplified this itself. Anyways, so I'll write this as 6 minus 6. So all in all, this, when I substitute p prime of minus r, so that would be 1 by 3 pi minus 2r plus 6r. So this would be a positive value, indicating this is minimum. While r by 3, let's see what it does. So minus 2r minus 6x, that is minus 6 into r by 3. So this is clearly a negative value, indicating this is the point of maximum. So from this I can conclude that at x is equal to r by 3, we have the maximum volume. Okay, so with that fact we'll just have to substitute and we are done. So we have v, which is equal to 1 by 3 pi r square, sorry, my bad, pi r square h. So if I substitute, so this is nothing but, r square is nothing but, if you guys remember, r square minus x square and h is nothing but r plus x. So substituting x is equal to r by 3. So we have v is equal to 1 by 3 pi r square minus r square by 9 into r plus r by 3. So a bit of simplification and we have the answer. Here the LCM is 9 and 3 and so on and so forth. 1 by 3 pi. This would be 8r square by 9. And this would be 4r by 3. A bit of rearranging and we have 8 by 27, 4 pi r cube divided by 3. Right? So I kept 1 by 3 pi and r cube, 4r cube together. What is this? Yes, this is nothing but your volume of the sphere, and this is that other entity. So therefore volume of the cone will be equal to 8 by 27 times the volume of the sphere. Hence proved. Okay, yes. Yeah. So this is your answer.